you all should be seeing this moving process into the cloud software environments slide now. So we're going to kind of switch gears a little bit, and we're going to talk about environments and why you care about environments and why uh, you should always use virtual environments. So talking about Conda specifically, right? So what is Conda? So Conda is a combination virtual environment and package manager. So virtual environments are a really excellent tool in Python that enable you to isolate your different environments from not from each other. I suppose is the best way to put that, including the base environment that you'll hear about, that is the global environment that your global Python executable will use, as well as any other virtual environment that's also installed on your computer. So, for example, if you have a legacy program that you're trying to run that depends on Python 2.7, which has been deprecated for many years now, you can do that. You can still install that. You can run that just fine. You install a new that version of Python in a virtual environment, and it will not cause the inevitable havoc that it would cause if you installed it into your global operating system base environment. So there's a couple tools that were historically used to sort of manage these virtual environments that I have listed here. Venv and virtualenv. Those are no longer used in operational capacity, basically. Basically because we have these nice tools that have been developed that makes the management of these virtual environments so much easier. So instead of going through the process of creating a virtual environment, installing a bunch of packages, activating, deactivating the virtual environment whenever you need it, we have these nice tools like Conda, which enable you to create an environment, install all the packages you want, and then activate that environment all with one command, which is really excellent. So talking about Conda a little bit more in depth, like I mentioned, Conda is a virtual environment and package manager. In Open Science Lab, in all of our deployments, we use this tool called Mamba, and Mamba is a re-implementation of Conda in C++, which supports parallel package downloads and faster dependency solving. So basically, the takeaway is it's Mamba, but faster, which is perfect. Let's see. So the next note here, Conda channels. So if you start talking about just about anybody with Conda, you might start talking about Conda channels. And what these are the repositories of metadata where Conda figures out how to get the packages that it's installing, right? So you'll see the default channel in environments that have been created. You'll also see Conda Forge is the other big one, and the major difference between these two is that the default channel can contain licensed paid-only software, and the Conda Forge channel is developed by the community and contains exclusively free software. And then, of course, because we're talking about Jupyter Hubs and Jupyter Labs, we'll talk about the interactions between Conda and Jupyter. So there are a couple different things a couple different packages that have been designed to get Conda specifically and Jupyter sort of interacting and communicating with each other. So this IPy kernel package to register the environments that you're going to create with your JupyterLab instance. So you just install this package with your environment, and it just works automatically, which is kind of amazing. And then there's also this NB Conda kernels package. If you want to use multiple different types of environments inside a JupyterLab session, this is the package that enables you to do that. So, popular environments, even outside of Python, people use R, MATLAB, Julia. I believe that there's a Swift environment that people are starting to use, which is really interesting. And this is the package that enables you to do that. So talking about building environments, there's a couple interesting issues that you can have when you're building specifically in a JupyterHub. So building locally, it's typically very straightforward. It's usually just as simple as running the create environment command, and then you're done, which is really awesome. The Python, the people who developed the virtual environment tool have done a really excellent job of segmenting these environments so that they're entirely separated from the operating system environment and any other virtual environments that exist on your machine. Building in a JupyterHub, however, is not always that straightforward. You can end up with opaque errors sometimes when you're running packages. One that we've seen before is when we were upgrading between JupyterHub versions. We had environments that had been built in JupyterHub 3. We made the upgrade to JupyterHub 4, and all of the environments that had been built in JupyterHub 3 stopped working. And this was a little bit of a challenge to figure out. It took us a little bit of time, but sometimes, especially in an environment like this, just rebuilding the environment will fix your issues. And then, yeah, so having package versions that are compatible with the base JupyterHub environment. Jupyter expects that there's going to be some degree of communication between the environments. And the Jupyter service itself, the JupyterLab service. So if you have a package version that is incompatible with whatever communications protocol that the JupyterLab is running, then you can run into some issues there. Like, for example, we've had issues in the past with just that thing where we've had it's the IPy widgets package, I believe, and having the wrong version of that made it so that a couple of our interactive widgets that we designed for the notebooks wouldn't work, and so we had to downgrade and pin that package in order to make the widgets work in the way that they were supposed to. So having talked about a couple cons of building in a JupyterHub, one of the pros that's really awesome is that you can have these environments and then you can have them built into the actual server image that you are distributing with the JupyterLab itself. So you have an environment, you build the environment, you bundle that into your JupyterLab instance, and once you've done that, every person who starts an instance of that JupyterLab will get the copy of that same environment without having to do anything themselves, which is really excellent, especially when you are running a class, for example, is something where we've used this before. It's really nice because then you don't have to worry about, this environment is going to change dramatically. You can create something called a pinned environment, which I'll talk about in a minute. Um, and you can distribute that along with the image. And so everyone in your class will have the same environment. It's very reproducible, which is really, really excellent. So I've talked kind of about some higher level thoughts around environments, but how do those things change in the day to day? And oop, here we go. Environments in the day to day. So environments break. It's unfortunate, but these things do happen even when um, you work really really hard not to make them happen. Environments will break. Um, they break because packages can be removed. Um, you know, talking about these sort of pinned environments, right? Where I guess I'll jump ahead a little bit. So a pinned environment is an environment where you specify the individual versions of each dependency that that environment contains. So you create the environment and then you generate what some uh, package managers will call a lock file um, that locks down your repository and pins every version of every package that is being used in that environment. So you might imagine that this would be pretty safe, and 99% of the time, you would be right. Distributing these pinned environment files is a really great way to make sure that every person who receives these files is using the same versions of the environment that you are. But sometimes packages can be removed. So we recently had a pinned environment where one of a dependency of a dependency of a dependency suffered a security they had a security incident that they discovered, and they removed the version of the package that we had pinned. So once again, rebuilding the environment fixed that, which was really really excellent. But it was very unclear why the package was not being found in our pinned environment. Environments can also break because package dependencies can be in conflict. So um, Conda and Mamba and all these package management tools, they come with something that's called a dependency solver. And sometimes you have an environment where the dependency tree cannot be solved. They can't figure out a good combination of or a combination of these packages that will enable you to install them all with the appropriate versions. And sometimes that can be as simple as manually pinning some packages. So if you have, five available versions of one package and five available versions of another, and they're each compatible in different ways, you can pin package A, and the solver will know which version of package B that it needs to use just from that. Sometimes it's not that simple, and that can be frustrating, and you sort of have to evaluate that on a case by case basis. But sometimes you have to roll back several packages. It can turn into a bit of a spaghetti mess relatively quickly. And then I guess the last point here, including environment files in Git repositories. Um, this this is something, if you are distributing any sort of software that requires an environment, this is something that is really important to do. Um, Once again, sort of kind of going back to a point that I made at the end of my talk about Git, um, it helps people understand what your product is doing without you necessarily having to explain it as much, so they can see if you are, installing pandas and NumPy, you're doing some sort of data science, right? You're doing some sort of data analysis. If you are installing a bunch of visualization tools, then you most likely have a data set that you've curated that you're now working on visualizing, right? So these things can sort of clue in somebody who once again is new and maybe wants to contribute to the repository and the work that you've been doing, but doesn't have the extensive background of somebody who has been developing the code. Practical environments, cool. So we're going to move into the demo section for this talk. So I'm going to talk about building environments in Open Science Lab using a terminal, which is something that you could is not specific at all to Open Science Lab. And then I'm going to talk about using the notebooks that we've developed. So there's one specifically for the workshop that we've worked on, and then there's also a more general notebook that we've developed for the Open Science Lab environments that we provide as a whole. Let's see. That switch over properly? It did. That's wonderful. So starting off with the terminals. So if we go into our workshop book directory, close this.
Hey, Dylan,
we can see that one. Yes.
Sorry, can we just show people how to clone in that that workshop?
Oh, yes. Yes, that's a great idea. Thank you. So let's see. Yes. So if you go to the ASF GitLab, you can see the top repository here is this NISAR Early Adopters Workshop October 24 repository. So you can open that, and then I'm going to use this link because I have my SSH key set up, but it's very likely that most of you don't. So if you don't, you can go over here to this HTTPS link and you can copy that. I guess it's a good note that if you are using this, you won't be able to contribute back with the HTTPS link because you can't authenticate to GitHub, but you'll be able to use that and clone the repository like that without issue. So if I move this, okay, this is my home directory. You can see that this NISAR workshop folder is no longer there. So we're going to clone this repository. So it'll be as simple as git clone in the terminal. And then once again, I'm using the SSH link. Most of you are probably going to use the HTTPS link, but all you should have to do is run git clone. And then you've cloned it down the repository so that if we run another ls here and list out our current directory, we can see that we now have the Early Adopters Workshop directory. So if we go in here, you can see that in this repository, we've included an environment file, and this is really excellent. So if we go and we just wanted to take a quick look at this just to see what's going on, this is the environment that we're going to build. We can see the name up here is specified. We're going to use the Conda Forge channel, and then these are all the dependencies that we're going to be installing along with this. So if we wanted to install this, it's really nice. It's really easy because we use Mamba as our package manager. Because as I mentioned before, it's fast. I'm going to be using that here. So the command that we're going to use here is Mamba env create, and then we actually don't need to specify the name because the name is already specified in the file. So with the -f command, we're going to specify a file, and that file is going to be this environment.yaml file. So we're going to run this. And then Mama is going to start building our environment. And that is going to take a minute. So while sort of this is plugging away over here, I'm going to talk about the notebooks that we developed. So if we open up our wonderful little JupyterBook extension here, you can see that under the software environments section, there's this notebook. So install required software with Conda. So this is a notebook that Alex developed for this talk specifically, and this will do the same thing that that our command just did, along with a couple little additional bells and whistles here. So you see there's this prefix option, and then there are a couple of these other options here. So this is going to make it appear nicely in our launcher window here in Jupyter Lab. But you can see to create the environment, this notebook runs Mamba env create with a file that we random. So this this notebook is really nice, and I end up using these notebooks sometimes more than the terminal, especially when we're talking about this notebook here, which is the default sort of experience in Open Science Lab, Open SAR Lab specifically. So you have the ability to list a bunch of environments, and then you can see there's a little bit more here than in the notebook for the workshop, because we have different environments with different needs. Scripts that need to be run after some of these environments. It's a really nice way of managing multiple environments and making sure, once again, that everything is reproducible in a way that is good for everyone. Let's see. So yes. Okay. So I guess the last point here that I was going to make, let's see if this is finished yet. Yeah, so building these environments usually takes a minute, especially when you have, some of these larger packages, NumPy. You might end up getting a cup of coffee and then coming back. But if you had multiple environments installed, which I'm not sure do. Yeah, so you can see, so this Conda env list will list all of the environments that you have. And unfortunately, I don't have any other environments installed right now. But the way that I'm going to activate this environment, if I wanted to use it from the terminal, once I was finished, would be activate. And then we'll just say base right now. So this didn't change anything, but if I had not been in the base environment, then using this command, conda activate, will put you into the environment that you're trying to activate. Then, yes. And then sort of the last thing that I want to touch on is looking at an actual pinned environment. So we can come in here and just look at an example of what this looks like. Let's see, ARIA tools would be good. So this is an example of a pinned environment, and so you can see all of these packages are potentially dependencies of a dependency of a dependency, right? ALSA is a sound management package that you all probably have if you're running an Ubuntu image. So this is a sound library, which is sort of an interesting dependency for SAR data science notebook. But a dependency of a dependency of a dependency somewhere uses this library, and so it gets listed off and pinned in this file. And you can see there are a ton of these. There are a ton of these here. Somewhere around 387 different packages that are all dependencies of this environment. And once again, having one of these is really excellent because it means that anytime that I have an environment that I am distributing to anyone else, to the general public, they will all have the same copy of the environment that I have. And the way that these environments get generated is like this. So this will take a second to run, but what's happening here is we're using Mamba and we're selecting our environment and we're saying we want to export the environment. We're naming our environment, which is going to be the base environment. And then we're outputting that to this environment.yaml file. So if I were to look at that file now, you can see there are all of these packages in this environment. It's added both the Conda Forge and the defaults channel. So like I mentioned earlier, when you're creating these pinned environments, the defaults channel may contain some paid software. So it's usually a better idea to just remove this at all and just stick with the Conda Forge, which is guaranteed to be free and available for everyone. And as you sort of move through this, you can see even in the base image, there are a significant number of packages that are being used here, some of which are being installed with pip. You can see right here, these are all dependencies that are being installed with a different package manager in this environment. And then the last sort of thing that you want to do here is this is the executable prefix. And if you're going to distribute a locked environment, you want to make sure that you remove that so that the executable that gets linked to the environment is determined by a user's Conda executable. You don't want to have to be in charge of managing. Perfect. So I think that is it for the demo section here. And then once again, there's some resources on this slide. We're doing a little bit of reading about Mamba, some interesting tools that Mamba gives us. Because Mamba is, like I mentioned earlier, sort of a drop-in replacement for Conda. Checking out the user guide for Conda is always nice. When I was researching for this presentation, I learned about a couple things that they do that I didn't know about, which was really, really interesting. And then also reading the Venv documentation, kind of for historical interest. So Venv is the first implementation of virtual environments in Python. It's actually a part of the Python standard library. And reading about the way that they designed this and the specification, I thought was really fascinating. And then if you are interested in working with any of the tools shown here, specifically the OpenSAR Lab environments, those are all publicly available on our GitHub, and those are all designed specifically to work in a Jupyter Lab environment, specifically the OpenSAR Lab that we manage. But the unpinned environments as well should be installable on local machines and everything also.